Assalamualaikum and a very good day to the lecturers, the panel and the chairman. My name is ZayidSyahmy bin Norulhuda and I am supervised by Mr. Nasrudin bin Ismail, and my undergraduate project entitled The Further Technical and Economics Evaluation on Dual Fuel Diesel Electric Propulsion Plant of a Crude Oil Carrier. Now this presentation is divided into 5 parts, which is introduction, literature review, methodology, results and discussion, and conclusion. So let's go to the introduction.
Now, international shipping contributes 2 to 3% of global emission, and it could rise up to 250% by the year 2050. By using natural gas, you could reduce the CO2 emission by up to 25%, and it has a zero sulfur emission. Dual fuel are already applied on some LNG carrier, but not on crude oil carrier. The objective of this study is to produce the detailed design and drawing of the plant, and also to establish the economic performance of the plant. The scope of this project is the literature review of ship's DFDE power plant system, and also based on work from previous students. The operational pattern is typical for North and South America region, and the EEDI and EOI requirements are to be adopted. Now, the problem statement is to further identify the parameters that are affected for the conversion to the FDE, such as the LNG gas supply system, and the location of LNG tank and other subsystems in order to achieve a lower emission of greenhouse gases with regards to the economic evaluation of the conversion.
Next chapter is literature review.
So this table shows the comparison between the previous student and the continuation work. As you can see, the previous student has made literature review on LNG supply system and the tank type, and I intend to go further on LNG supply system as well as the location of LNG tank alongside the waste heat recovery system using gas turbine. For the economics, I will add payback period and internal rate of return. Now, dual fuel diesel electric propulsion system is basically a combination of dual fuel engine with electric system or electric motor. Dual fuel diesel run on natural gas as the primary fuel and heavy fuel oil as the secondary fuel. The pilot fuel used is the heavy fuel oil or the marine diesel oil to kickstart the engine, because LNG cannot ignite by itself. It can operate with a mixture of 99% gas and 1% fuel or 100% fuel oil. Due to its fuel flexibility, you can operate it with natural gas when available and on diesel alone when necessary. Now, the energy efficiency design index is introduced in 2013 in an effort to reduce ship emission. It is applicable to all new ships as well as ships undergoing major conversion. The basic formula is that the carbon dioxide emission will be divided by the transport work.
The next point is methodology.
So the methodology for this semester is the technical parameter analysis and calculation, which include the energy balance, the LNG supply system, which includes the fuel consumption, the cooling water system, and lubricating oil system. Next is the system design drawing will be conducted using Rhinoceros 3D and AutoCAD alongside the waste heat recovery system. And finally, the evaluation for EEDI and EOI, followed by the economics evaluation.
And now, results and discussion.
So the reference vessel used is MT Excello, and this table shows the difference in terms of the power plant. For the original vessel, it uses 3 genset, but for the dual fuel, it used 2 genset. But the dual fuel provides more total overall power. The energy balance is used to identify percentage of an actual engine useful work. And in comparison, there is a difference in terms of total power output, lubricating oil, and exhaust gas percentage between the dual fuel and the original plant. The route for the vessel is from Port Arthur to Rio de Janeiro and then back again. Single distance will be 6,378 nautical miles, assuming that the available time per year is 350 days, so the vessel will have just 11 trips per year. Fuel consumption is important for any engine, and in this case, for dual fuel, the specific fuel consumption will be 0.252 kg per second for LNG and 0.19 kg per second for full diesel. While for the original plant, the specific fuel consumption is 0.182 kg per second. In order to achieve the route, 47 tons of pilot fuel will be used for the dual fuel, and 625 tons will be used for the LNG. If the vessel uses full diesel, it requires 780 tons per trip. Compared to the original plan, it only requires 705 tons. This is the fuel gas system. The LNG pump will suck and transfer the LNG from the storage tank to the vaporizer. The vaporizer will then change the LNG from liquid phase to gas phase, and it acts almost like a heat exchanger. The gas valve unit will then regulate the feeding pressure of the gas to the engine. The distance between the gas valve unit and the engine is at maximum 10 meters. This is the fuel gas piping system. All the LNG piping will be double wall pipe for better safety and insulation, and the LNG supply system components are interconnected to one another for better reliability. Now, according to DNV, the distance from the site must be b divided by 5, but not less than 760 millimeter. For this ship, the b is 27 meter, and therefore the minimum value is 5.5 meter, and I have designed the LNG tank to be placed 6 meter from the site. There is a difference of 195 kilowatts in terms of Q jacket water for the cooling water system, and the cooling water will remove out hot surface or material from the genset. And from that, the area of heat exchanger also has a difference, by which 4 new additional plates will be needed to remove the extra heat. Also, the freshwater and seawater pump also need to be changed because there is significant difference in terms of flow rate between original plant and the dual fuel. The same goes to the lubricating oil, but however, the specific lube oil consumption for the dual fuel is higher than the original plant, but the lube oil consumption for the original plant is higher because it has 3 gensets compared to 2 gensets of dual fuel. In terms of area of heat exchanger, 1 more heat exchanger plate is required to remove the extra heat if we use the same oil cooler as the original plant. In order to improve the efficiency of the plant, the waste heat recovery system works by converting wasted exhaust gas into electrical power. So I have analyzed between waste heat recovery steam turbine and gas turbine, by which the gas turbine produces 3,260 kilowatt of power output compared to just above 2,000 for the steam turbine, which means that gas turbine is better than the steam turbine. The EEDI requirement for this vessel is at 6.794 gram per CO2 per ton, and therefore the attained EEDI analysis of this vessel for dual fuel with waste heat recovery, it passes the required EEDI requirement, but for the original plant with waste heat recovery, it only passes IMO Tier 2. In terms of capital cost, however, there is a 55% difference for the original plant with waste heat recovery and the dual fuel with waste heat recovery system, by which it is expensive to convert to dual fuel. In terms of operational cost, however, there is a minimum difference of 11% between dual fuel with waste heat recovery and original plant with waste heat recovery. Now the OPEX parameter includes the price of LNG, the price of marine diesel oil, the price of lubricating oil, genset and waste heat recovery system maintenance, propulsion maintenance, and general spare parts per year. According to NIMCO, the average daily earning of crude oil tanker is $20,000 per day, which means that the annual revenue is just above $7 million per year. And the salvage value for this vessel after conversion to dual fuel is $0.734 million after 20 years. In terms of net present value, with $20,000 per day, the NPV value will be negative. So in order to obtain a positive NPV value, the minimum daily income will be $30,000 per day for the DFDE and $25,500 per day for the original plant to obtain a positive NPV value after 20 years. In terms of payback period, with $20,000, the payback period will be negative for both cases, and therefore the assumed profit in this case will be the environmental benefits due to reduced emission level and lower EEDI value. But if we change the minimum daily earning to $30,000 and $25,500 per day, the payback period will be 14 years for the dual fuel and just below 20 years for the original plant. To support the NPV, we use the IRR in capital budgeting in order to estimate the profitability of an investment. Again, with $20,000 per day, it is unable to calculate IRR because the income per year is negative. And therefore, if we change the minimum daily income to $30,000 and $25,500 per day, the IRR value for the DFDE with waste heat recovery is 3.54% and 9.30% for the original plant with waste heat recovery. And therefore, the investment with lower IRR generates greater cash flow than higher IRR value.
And finally, conclusion.
So the technical and economic parameters are obtained and the objective is achieved. The emission problem is drastically reduced. With current prices, the DFDE operational cost for fuel is an advantage, but maintenance cost is too high. So this project is technically compatible but economically not feasible.
That's all from me. Thank you to the chairman and the panels. Hope you understand the video and stay safe.